the revision. So this is about the Gini measure, and then we also looked at the naive Bayes classifier, right? So some of you are asking about Laplace smoothing. So that Laplace smoothing is will be applied here, okay? In naive Bayes classifier, that is a probabilistic classifier. So example was that we discussed was about spam versus ham emails. Okay, so ham is nothing but that is not a spam. Normal mail is called ham, and the spam mail is called spam. Okay, so there is a very small example here. That the training example is very small here. So you have 5 documents in the training set. Out of that, 2 are hams and 3 are spams. Okay, so the probability of ham is is 2 by 5. Probability of spam is 3 by 5. Okay, and then the content of the document is like this: good, very good, bad, very bad, very bad, very bad. So these are the content. So you have to learn or train a naive Bayes classifier from these documents, and once that is trained, then you want to see how this will be performing, how this new document, that is D6, containing good, bad, very bad, how this will be, whether this will be labeled as spam or ham mail. Okay, so this is the test document, you can say, and the initial 5 are the training documents. So in naive Bayes, you know that you just calculate the probabilities, right? Some probability. What is the probability of different words based upon and the documents? So you multiply them together and get some resultant probabilities, which will be used in D6. Okay, you will see in this case. First of all, what you do is, so you apply the Bayes theorem that all of you know about. So basically, what you want to do here is, you want to calculate the probability that it is a spam mail. Okay, given that, what do you know? You know that the document, you know about the document. You know about the documents containing words. You know what words are there in the document. So D6 is nothing but you know about the document. Okay, so given this document D6, what is the probability of a spam mail? And also, what is the probability of ham given document D6? Okay, so you just calculate these 2 probabilities, and whichever is bigger, you will. So bigger probability means bigger chance. So you will label that particular document as belonging to that particular class. Okay, if spam is bigger, spam will be classified as spam. If ham probability of ham is bigger, this will be labeled as ham. Okay, and we know about the naive Bayes classifier. It says that probability of any event A given B can be calculated as reverse those, right? Probability of B given A then multiplied by probability of A and divide everything by probability of B. So that is your Bayes theorem. The same thing will apply here. So what do you want to find? You want to find probability of let's say spam given document. So A here is a spam. Okay, spam mail. Given that is spam mail, and B is the D6. Okay, so for that we want to calculate probability of spam given D6. So according to the Bayes theorem, it will be just opposite of that, right? So you reverse this: probability of D6 given spam multiplied by probability of spam. So you can see that we are applying the same formula that I've written on top. divided by the probability of D6. Okay. And one interesting thing here is you will see is that the denominator probability of D6, you don't actually have to calculate this probability of D6, okay, because it is common to both. And even if you have probability, if you want to find the probability of ham given D6, D6 will come in the denominator. So this probability of D6 you don't have to calculate. Okay. So basically what you have to calculate is probability of D6 given spam multiplied by probability of spam. Okay. And also you have to calculate probability of D6 given ham multiplied by probability of ham. Okay, and probability of spam and probability of ham we already know from the overall data that we have got. Probability of ham is 2 by 5. Probability of spam is 3 by 5 because there are 3 spam documents available to us out of 5. So 3 by 5 is the probability of spam. 2 by 5 is the probability of ham. So the second term in this factor in the numerator is already known to us. So what remains to be calculated is probability of D6 given spam and probability of D6 given ham. Okay. So let's calculate the probability of D6 given ham. Okay. So probability of D6 given ham. So D6 is nothing but this is a document, right, containing a few terms, few words. So in D6 you can see that there are 4 words: good, bad, very bad. Okay. So one of the assumptions of naive Bayes classifier is that all the features, all the different features are independent of each other. Okay. So that is in this case the presence of any word here is independent of presence of any other word. Okay, that is the meaning of independency. So all the features, all the words here, so whatever are present, are independent of presence of any other word. Okay, so when that happens, and you want to calculate probability of D6, say given ham. Okay, so in that case, what happens is it becomes just probability of each individual words. Probability of good, first word is good, given ham. Okay, so they can all be multiplied together because they are all independent. Okay, so probability of good given ham. So we got a good given ham multiplied by probability of bad given ham. Second word, third word is again very. So probability of very given ham. Okay, and multiplied by probability of last word is bad given ham. So let's just look at all the words in sequence and multiply their probabilities. Okay, and how do you calculate the probability of let's say first word, probability of good given ham? Okay, so for that you just look at the individual the documents which are labeled ham in the training set. Okay, so there are 2 documents labeled ham. Okay, so in these 2 documents you have 2 good, there are 2 words good, and there is 0 bad word and 1 word very. Okay, so 2 good, 0 bad, 1 very. So from there you can actually find out. So that has been done in the previous slide. Okay, that is not been done here. I think only for spam it is calculated. Oh, here it is. Yeah. Let me just clear everything here. Okay. So here let's calculate probability of very given ham. Okay, so here when you calculate each individual word's probability, we apply the Laplace smoothing. Okay, so in this case probability of very given ham. So we'll just calculate how many of words are very. Okay, so how many very are there? 1. So then Laplace one is smoothing, so just add 1 to every count here. Okay. So count of vary given ham plus 1. So vary is, there is one vary in ham, so there are two ham documents labeled ham documents or two documents labeled hams. In these you have single one vary, right? So one vary means 1 plus 1 is the count of vary. Okay, divided by, so the probability of vary given ham will be the count of vary and plus 1 smoothing anyway, divided by the count of every other document plus 1, just every other word. So what is count of vary is 1. So that there are three. So in the vocabulary we have three different words: very, good, and bad. Only three words are there in the vocabulary. Okay, so just count each word in that label. Okay, how many words are present of that kind, and then add 1 to each. So there's one vary. So 1 plus 1 is added here. Then how many goods are there? There are two goods, right? There are two words good. So 2 plus 1, again Laplace plus 1 is smoothing. 2 plus 1 for good. And how many bads are there? There is no bad, 0. So 0 plus 1. So for every word you are adding just 1 to that. Okay, so this is the probability of vary given that or you know that the document is ham or the email is ham. So the probability of vary is this much. So probability of vary given ham is this much. Okay, now I'll just hide that and let me ask you, can you calculate probability of good given ham? Good given ham. Again Laplace plus 1 smoothing will be used. Just calculate what is the probability of good given ham. So what is the count of good? 2. So 2 plus 1 is 3. So numerator will be 3 and the denominator will be again 3 plus 2 plus 1, right? 6. 3 by 6, right? So that is 1 by 2 or 0.5. Now comes the important part. Let's try to find the probability of bad given ham. Now you can see that there is the bad word is not present at all in ham. Okay, but does it mean that it will not be present anytime in the future? It is not. There is no guarantee, right? So it may come sometime in a document of type ham, the word bad, even though in the training document it is not present. So that's why Laplace plus 1 smoothing is important. So now you see. So what is the probability of bad now? So it has occurred 0 times. So 0 plus 1 by 6. Denominator is again 6, just like earlier. So 1 by 6. Okay. Now if you had not applied Laplace smoothing, then the probability of bad given ham would be 0, isn't it? 0 if you have not applied Laplace smoothing, and that would be a problem. The probability of any word given one of the labels is 0, that is a problem. And why is that? Because in such case what will happen is any document that any unlabeled document that you want to find its label, okay, that contains the word bad, in this case its probability will always be 0, because this probability of bad given ham will be used there, and its probability and it will be 0, so it will make everything 0. So in the future none of the documents containing bad in this case will be labeled as ham. Okay, that is not what you want. What you want is give it a very small probability, so this will be there. helpful. So you can see in the calculation, probability of ham given d6, also probability of d6 given ham, okay, because you still used a very small probability, right? 0.17 per pad. Okay, because you used very small because you used 1 by 6. Okay, so you got probability of d6 given ham as 0.0048. Okay, and because of this, the probability of ham given d6 came out to 0.0019. Okay, if that was not used, if you had used, if you had not used Laplace moving, then this would be straight 0. Probability of d6 given ham would be straight 0, and because of that, this probability of ham given d6 will also be 0 entirely. Okay, but it might be the case that in the future, somewhat might be present, but still, the bad may be present, but still it may be a ham document. Okay, for example, if we had some document, let's assume something that contains a, let's make it a bit ham like, let's say it contains good 3 times. Okay, let's see, hopefully it will work now. So let's make it 4 times so that it is more of ham. Okay, and bad ones. So 4 good and 1 bad. So what would be its so in case of in case if you didn't use Laplace moving, okay, it would be anyway the probability of ham given d6 will always be 0, because the bad will make the probability of any document containing bad to 0. Okay, whereas right now by using Laplace moving, this probability here might be bigger than the probability of spam. Okay, because of presence of these positive words good, which are more relevant to a ham document. Okay, so to prevent this kind of cases where the probability of entire conditional probability becomes 0, you use Laplace moving. Okay. Okay, there's a question. While calculating d6 spam or ham, will not apply Laplace moving? Yes, Laplace moving is always used for individual words probability. Okay, once you've got those probabilities, you can then build on the later one. Okay, you got it. Good. Okay, so this is clear. So in this particular case, as it happened, the probability of spam is more. Okay, one more thing you can see that the probability of d6 is not required because in the denominator both have this common, right? So you don't have to calculate this. All the numerator is calculated, and the numerator value of spam is more. Spam given d6 is more, 0.006. Okay, for ham it is 0.0019. So because probability of spam given d6 is more, this will be labeled as spam. This will be labeled as spam. Okay, in this particular case. Right. So that is about the classifier, naive Bayes classifier. Okay, then I just discussed very briefly about the ensemble methods when you create ensembles of classifiers. Okay, so what you do is basically you just combine 2 or 3 or more very strong classifiers which are giving good results and which are giving different results, okay, which are not agreeing completely, and create an ensemble of that. And ensemble means combination of those, just combine the output of those and maybe use something like majority voting. So if three classifiers are there, all three are good classifiers, okay, they are individually performing quite well, then you can just look at, and let's say these three classifiers are also not classifying similarly, okay, so they are not all classifying say ones or zeros at the same time. Okay, so if that is the case, then you can actually build ensemble, so you can combine the three and get a very good result, better result. So in this case, what happens is that you do something called majority voting. So we apply those three classifiers, and let's say you have two labels, plus and minus, positive, negative, and in the majority voting, what happens is that if two classifiers are saying positive, okay, then it will be termed positive. If two or more, so it is majority voting, or if two or more are saying negative, then it will be labeled as negative. Okay, so using this kind of ensemble methods actually results in improvement of the classification. Okay, so ensemble is nothing but just a collection of individual classifiers. Okay, so because the combination of these classifiers, they will supposedly improve the overall accuracy. Okay, and there is mathematics behind that we have not gone into, but there is some mathematics behind that, and why it is true. Okay, but what you can think about is, like, let's say, okay, let's assume that, okay, let's assume that you have three classifiers.
Gracias.